All right, you guys, I made this video once and it had no sound. So I already wrote out the notes, so I'm just going to go through them with you. And as you know, pause and get the notes down. I just don't want to make the video super long where I'm writing everything down. Okay, so we are going to start chapter 10. This is 10.1, and we're going to look at what is a series. Okay, and it's really easy to get a series and a sequence confused. And a series is just the sum. Okay, so whenever you see that capital sigma, it's a capital S in Greek, just telling you, add up all those terms from the sequence. Now, I kind of remember, because I used to always get them confused, sequence, series. So a series, I just think of the World Series, and that you have to add up how many games they won. Okay, so they're pretty simple. Okay, so something like this right here, all this is telling us to do, the number at the bottom is telling us which term we're going to start with. Now, normally it's always the first term. The second most normal is that it's the term 0. Okay, and we'll talk about that. It doesn't really matter if it's a 0 or a 1, and we'll see as we go along why. Okay, so this tells us where to go up to. Okay, so we're going to start with the first term, and we're going to add up to the fourth term. Okay, so I just put in 1, 2, 3, and 4 right in there for n, and there's my sum. Okay, and remember that you want to get those values memorized because you want to recognize when you see a pattern and that the pattern is of factorials. Just like you guys see a pattern of powers of 2 or odd numbers, even numbers, whatnot. Okay, now we're going to talk about, in this section, infinite series. Okay, we will see that we'll talk about some things like this in a minute here, but mostly we're interested in infinite series. And all that is the summation of a sequence with an infinite number of terms. Now, it seems like, well, how could you add up something with infinite number of terms? And just like we saw with integrals, that we could find the area under a curve that went out to infinity. So sometimes those last terms, if they're super, super, super small, that they almost turn into nothing, we can find the sum. Okay? So it's going to look like this. It's going to have an infinity at the top. Okay, so we just say, okay, we're going to add up the first term, the second term, the third term, and then we call this the nth term. Okay, whatever term do you want, the fifth term, the 10th term, whatever term. Now, I can't say it's the last term because it's just the nth term because this goes to infinity. All right. Now, another thing that we might be asked to find are partial sums of an infinite series. Okay, and partial sums, all that is saying you have an infinite series. We want you just to find the sum of the first 3 terms. How about the first 5 terms? Maybe we want just the first 10 terms. Okay, that's all that that's saying. Okay, so let's say we had to find the partial sums, and we were given this guy right here. And we're told that it's an infinite series, and we want the sum of the first 2 terms. Okay, so it's important for you to note that when we want partial sums, we call it S, capital S. We'll also see that if we could actually find the sum of all of that, we would just call it a capital S, meaning the sum of the series. But that little 2 right there says, I'm going to find the sum of the first 2 terms. Okay, so all I do is I plug in 2 for n, I start with 1 because I want the first term plus the second term. And that's what I'm going to get. Okay, so pretty simple stuff. Okay, if I want the sum of the first 5 terms, okay, I'm going to say the first term plus the second term, and then I'm just plugging in my term numbers for n. And if you've got a common denominator, you added this all up, it would be 31/16. Okay? Okay, so what if we wanted the sum of all of the terms, the infinite terms? Well, just like the integral, we can only do that if we know if the series approaches a number. Okay, and if the series approaches a number, we say that it converges. And we have some things, there's some that we can easily find the sum, some that we can estimate it. But the main thing I want you to note is we have to know if the series converges. So we're going to use this series for all types of things. And this is going to be really important. Okay, so our goal in this chapter, or at least the first half of this chapter, is we're going to use tests to determine if a series converges or diverges. Because if it diverges, remember we talked about with integrals, it's meaningless to us. It just goes off to infinity. We can't really work with it. So it's really important to know what we have first. Okay, so remember I gave you guys this on Tuesday, and for some of you guys in class today, these are all the series that we're going to learn. Now, it might seem kind of overwhelming at first, but you'll see that many of them are very small little tests, okay? And so what we're going to use with this is we're just going to get everything organized, okay? And that's it. That's all we got to do for how we start dealing with these. All right, see you later.